Hi all, welcome. Today I'm here to present how AI is transforming enterprise data pipelines with performance efficiency up to 70 to 85%. Powered innovations are revolutionizing the data engineering workflows. In the context of today world, artificial intelligence is having a major impact on enterprise data pipelines, and the data engineering transformations are happening across the entire data lifecycle, from ingestion and processing to. It is about myself. I am Gopinath Govindarajan with 15 years of experience in data engineering with a focus on cloud technologies and automation. I consistently pioneered innovative solutions that bridge technology gaps and deliver measurable business impact. Um, Also spearheaded the implementation of cloud-based data lake solutions that changed how the organization handles large-scale data. So back to the topic of the enterprise data pipelines. AI can detect the data patterns and automate the connections between different systems such as cloud, on-prem, APIs, etc., drastically reducing the manual, and also it's having an impact on the data quality and cleansing, smart orchestrations, and we can implement the faster and smarter analytics with an enhanced data governance and security. So thereby you giving the result in the real world measurement up to 85% gain in terms of efficiency. What is the data challenge we have currently arised? On a daily basis, we are generating 2.5 quintillions of data. With this amount of data and the different challenges in handling the large volume, this efficiency gain of 85 human intervention. We will discuss more on this topic. So the if we delve a depth into what kind of challenges we are facing in terms of data. So the first one is the data silos and fragmentation. It is often spread across the multiple systems, making it difficult to create a unified view, integrate and process efficiently across the different data sets. Because why it's a problem, data engineers spend huge amounts of time just locating, extracting, and normalizing the data. And the second, I would like to highlight the data quality, right? Most of the times it seems to be poor. So the organizations struggle with the missing or incomplete data, such as the duplicates, inconsistent formatting, and also the schema drift, how it impacts. We could the garbage in, garbage out. So the dirty data leads decisions we cannot make it more efficient, right, in terms of business. And also the complex orchestration in terms of the transformation when we do ETL or ELT jobs across the dependencies, schedules, and environments. Coordination most of the time seems to be tricky. So failures can cascade. And the next one would be the performance bottlenecks and the scalability. As the data volumes grow, pipelines need to scale horizontally. Many legacy systems, most of the times, it is poorly optimized. The pipelines can't keep up. And the last one could be data governance and compliance, right? Keeping up with the data policies such as GDPR, HIPAA, CCPA is hard. So the challenges include tracking the lineage, the RBAC, role-based access control, and the classification of the data in terms of sensitiveness. So these are the different challenges, right, we are facing. And the solution, how can we find it like in this slide, automated feature engineering. So what is about how it can address the data challenge? So this is an AI-driven game changer in the data science and machine learning pipeline because it uses machine learning heuristics and domain knowledge to automatically generate, select, and optimize the features from raw data without much traditional way of and feature engineering. What it is all about, it's a process of transforming the raw data into the meaningful inputs. When I say inputs, it's a more of a features for a machine learning model. Traditionally, this is manual, time consuming, and highly dependent on the expertise knowledge of a particular domain. So now comes the rescue. AI driven automated feature engineering flips that by using algorithms to analyze data types and its relationships, generating the new features such as ratios, time lags, aggregates, encodings. Rank and select the best features, continuously optimize features for model performance. It's often powered by the famous tools like feature tools by Alteryx, H2O.ai, Amazon SageMaker, Autopilot, Google AutoML, Data Robot, to name few. And what are the key techniques being employed in this engineering in a more automated way? The number one is a deep feature synthesis, DFS. Automatically builds the features from relational datasets. And the next is recursive transformation, creates the layered and higher level features, embedding and encoding, which is a technique used to convert the categorical or textual data. What are the algorithms can be used in the feature selection? Using a correlation method, mutual information, or shift values to drop low value features. Moving on to the next slide, which talks about data cleansing, right? How it can be employed in an intelligent way compared to the traditional methods, which will give us the improvements in terms of detecting the anomalies in the data. And also, we can implement the correction of data in a more automated fashion and how to recognize the patterns. So it's a data cleansing, intelligent data cleaning is more of is a use of AI, machine learning, and advanced automation to clean, validate, and enrich or enhance the data more precisely and efficiently compared to traditional methods. Instead of relying on static rules or manual review, intelligent cleansing adapts to the patterns, context, and domain specific logic to ensure high quality, usable data for the different purposes, such as analytics, reporting, and obviously the machine learning. So now comes the question, when we say the data cleansing, what makes it intelligent? Traditional data cleansing involves manual scripts of fixed logic, like removing the duplicates, filling in null values, and standardizing formats, to name few. On the other hand, intelligent data cleansing uses smart algorithms that can learn and adapt itself. We came across in the data cleansing, most predominant one is the missing values. So, how this intelligence can help, right? Predicts the missing values using the ML models, such as KNN or regression models. And the next one would be outlier detection, using statistical or AI models to flag the anomalies, not just thresholds. Then the data normalization comes in. How can we intelligently cleanse the data with respect to the data normalization by learning the patterns, right, in text, dates, addresses, etc., and autocorrects it. And the entity resolution using fuzzy matching or the NLP to merge duplicates, such as you can say IBM Corp versus international business machines. And data enrichment plays an important role, right, in terms of missing attributes by putting from external sources like business databases or geolocation APIs. We can achieve and improve the or enriching the data in an efficient way. So, what would be the next step when we successfully cleanse the data? It's going to be an interesting topic for all of us, right? The entire SDLC, how can we integrate, right, using the MLOps? So, it is a practice of combining machine learning systems with DevOps principles to streamline the life cycle, right? Development, deployment, monitoring, and governance of machine learning models in production. We can consider to think it of as a glue between data science and engineering, turning experimental models into a robust, scalable, and continuously improving business systems. So, what it integrates? The life cycle, we'll see. MLOps connects multiple workflows such as data ingestion, versioning, model training, and experimentation, model packaging and validation. And the next one would be the deployment, CI/CD for ML, model monitoring, performance, drift, retraining, and the feedback loops. So these are all the some workflows where we can integrate, right? The first one would be CI/CD pipelines for machine learning. Yeah, what is the purpose of it? It can automate model testing, validation, and deployments. And the second component would be model registry. So that can track versions, metadata, and lineage of different trained models. And the third component would be feature store, which can be a central repo for consistent, reusable features across multiple trainings and inference. Automated retraining, triggers based on data drift or model decay. Monitoring tools can be used for checking the accuracy, latency, drift, bias. These are the different components of the integration of a machine learning ops model. Moving on to predictive quality monitoring. Monitor the quality, which is critical for any business. Sorry. Statistical modeling and sensor data to detect patterns, forecast the deviations, and identify quality risks before they lead to defects or failure in a product or the process. So, what would be some of its benefits that we can see? Reduced defects can be one of the benefit, so we can catch the issues before final product is made. A lower cost of quality, we can prevent the scrap, rework, and warranty claims. And the real-time decision making, which is really helpful to fix the issues in process rather than post-production. And also it will improve the yield and efficiency, which in turn will maximize the output while keeping the high standards. And if there is a issue even in production, the benefit would be having a predictive monitoring would be the root cause insights where we can identify key variables affecting the quality and thereby improve upon it in production. Regulatory compliance, which is key organization, whether it's a retail, manufacturing, finance, or healthcare, the compliance is sensitive, right? So further, it will have an impact maintaining the consistent quality for audits and certifications, having a monitoring method which is predictive. We can say as an example, right? The predicting health or medical condition sepsis in real time. A hospital uses an AI model trained on vitals plus labs data. For example, we can say heart rate, WBC count, lactate levels. So system predicts sepsis risk hours before the symptoms actually show in the body. Sends alerts to the care teams. They can give or provide early antibiotics and fluids. which in turn can reduce the mortality rate by 20 to 30%. That's cool, huh? Moving on to data enrichment. How can we drive it? So it uses intelligent algorithms, right, to analyze existing data, detect patterns, and augment it with additional attributes, either from external sources, derived insights, or automated predictions to increase its quality and utility. We can quickly see the different types of data enrichment, right? So first is raw data from the legacy systems, unstructured content harvested from the disparate enterprise sources, and enhanced insights which can deliver a 56% greater analytical. So these are the different types, right? The one popular one would be the text enrichment using the natural language processing NLP. What it does basically extracts the such structured data from unstructured text, right? So the example would be pulling the job titles and skills from the and image or video enrichment. That is one of the typical type. What the AI is doing is uses the computer vision to label or classify the media. And the best example would be tagging the product photos with the categories, colors, and objects. And the next one would be geospatial enrichment, where we can, it basically, what it does is adding the location based data from GPS or address fields. The typical example would be attached weather, region risk, or store proximity data. So this is how AI is powering, right? So it's a smart system that manages the history and evolution of digital artifacts, we can say, such as code, data, models, documents. Everything requires the version controlling, right? But how can we achieve it using AI to automate tracking, detect changes, suggest actions, and optimize collaborations across multiple teams and pipelines? So, what are the few benefits of having intelligent version control? So, smarter collaboration, faster conflict resolution, and to detect the semantic conflicts and suggest the resolutions intelligently. Also improves auditability, better traceability, automatically logs the model, data, and code lineage, vital for the regulated industries such as finance and healthcare. Also, this version controlling in an intelligent way improves the models and data management, like how changes in data sets can be tracked quickly and efficiently, or the features impact the model accuracy, and also effectively supports the rollback to known good configuration if any issue occurs. Reproducibility enables the full experiment tracking and rerunning the pipelines with the exact inputs and parameters. And also, with all these benefits, right, it can save the time and also automation in an efficient way, like intelligent merging, auto tagging of versions, change summaries, etc. So, what are the different popular tools available now in enabling the intelligent version control? Would be DVC for the data and YAML versioning, YAML flow is there, GitHub Copilot is the AI assistant, smart code versioning. Yep, this is all about version control. And we can see about case studies, right, which are implementing these mechanisms. So, yeah, one of the financial services company that they have booster analyzed data, analyzed the productivity by 37%, enabling the deeper market insights. So by tailoring the intelligence automatically delivered to each team member based on their specific role and also the historical pattern of interactions. And one of the healthcare provider automated successfully, you could say 73% of critical classifications while maintaining the strict compliance standards, HIPAA. And also They can see the advanced intelligent classification and masking technologies helped them to complete the sensitive data and the protection of patient information, PA and PHI. And one of the retail organization, these algorithms and machine language processed high value market data to be precise 2.8 times faster, creating significant advantage over the competitors. So this time sensitive revenue driving insights delivered ahead of their competitors in the industry, directly impacting their results quarterly they can see. So these industry leaders in the different segmentation, I've seen their data operations through the strategic implementation of these different AI techniques we talked about. Their transformative results include a dramatically insights acceleration and also reduce the operational costs, and particularly for the finance and healthcare businesses or industry, they could see an enhanced compliance regulatory across the industry. So this conversational AI assistant in a day-to-day life, everyone will be coming across with the AI assistant. It's a virtual agent powered by AI that interacts with the users like us using the natural language, basically text or voice, which automates a lot of tasks and provides information and enables a self-service across the digital channels. It mimics human conversation patterns and often supports multi-turn conversations, context retention, and personalization. Yeah. And what are the core technologies involved in these agents used as a AI assistant? You, which basically understands the user intent and entities, natural language generation, NLG crafts meaningful human-like responses. Dialogue management manages the flow of conversation, and machine learning LLMs, for example, the good example would be GPT, powers adaptability and reasoning, right? Speech to text to speech converts a spoken input output for voice assistance. And APIs and integrations are quite popular, connects with the backend systems, CRMs and databases. So this is about AI assistant, how can we interact with them efficiently? Yeah, with that, it concludes this presentation. Thank you all for joining this session. Yeah, before we wind off, let me conclude with the data engineering, how it transforms. It's not just about adapting new tools, it's modernizing the workflows, embracing the automation, and aligning with business goals, right? To create a scalable, agile, and intelligent data foundation. So I can provide the quick roadmap style to transform these data engineering practices effectively. So adopt a modern data stack used in ingestion, storage, processing, orchestra, load and transform. Integrate AI ML for intelligent workflows, so which will help full for any business in auto detecting schema drift, to predict pipeline failures, enrich data intelligently. Implement data observability. Treat data pipelines like production system. Monitor the freshness, accuracy, volume, lineage, and alert for anomalies or downtime. Use tools like they're quite popular Monte Carlo, Databand, and Big Eye. Test and version everything, which is the critical one, right? Data testing, data versioning, and model tracking. And wherever the automation is possible, can be effectively implemented using the data ingestion pipelines, event driven or scheduled, data quality checks. So the goal is to reduce the manual ops and increase pipeline reliability. And finally, try to foster your DevOps culture. Treat data as a product, not as a byproduct. Yeah, with this session concludes.